Welcome to Lecture 2 of the BBE 2003 course. This week we are going to talk about MATLAB programming basics. So in Lab 1, you already practiced MATLAB basics, and we will continue talking about more basics regarding MATLAB programming. And we have 4 subtopics. First is matrix manipulation, then script, and then function, and in the end we talk about flow control. So the first 2 are more case-specific for MATLAB programming, and the function and flow control are major or typical topics in any advanced programming languages. So MATLAB stands for Matrix Laboratory. Here you can see how important matrix is in MATLAB. A 2D matrix usually refers to a 2-dimensional array consisting of m rows and n columns. Special cases are column vectors, where n equals 1, and row vectors, where m equals 1. The following basic operations in matrix manipulation were already introduced and practiced by you, such as entering a vector, entering a matrix, matrix vector indexing, colon operator, built-in functions, and transpose. And we will continue the following basic operations, such as create a submatrix, edit a matrix, matrix dimension, matrix calculation, concatenation, and some special matrices. And first, we are going to talk about submatrix. Given a 3x3 matrix A, we can get a submatrix from matrix A, which is B here, by indexing. And also, we can rearrange some items in the matrix, such as the way we create C. And we can also index out a single row or column, like what is shown on the right-hand side of this slide. And also, please watch a MATLAB demo about creating submatrix. And more about matrix manipulation, editing a matrix. So we can make the third row of matrix A to be empty. Just remove it by using A3 colon equals an empty space. And also, if we do something like the lower left, which is A equals A1 colon semicolon, A2 colon semicolon, and 7, 8, 9, we get the same original matrix A. And we can set a single item in matrix A as 0, such as A33 equals 0. And also, we can rearrange matrix A from 2 dimensions to 1 dimension, using A equals A colon. And again, please watch a MATLAB demo on editing a matrix. And for measuring the dimension of matrix or vector, we can use length and size. For a vector, length returns the size of the vector, for example, m equals length A. For a matrix, size returns the sizes in both dimensions of a matrix. And we can use bracket m n equals size A. This will return 3 and 3 for the previous A matrix with the size of 3 by 3. And next, we talk about matrix calculation. And you can find a lot of information about arithmetic operators like the following in the following list. And feel free to use help to explore how these work for matrix. And we are going to demonstrate the use of some of them. So here, the matrix calculation including multiply, dot multiply, and slash or right division or dot right division. And again, you can see a demonstration of these operations in MATLAB in one video with the title as matrix calculation. And next, matrix concatenation. By its name, we know it's about adding up things or expand things by concatenation. So here we give two example matrices. A equals 1, 2, 3, 4, and B equals 1, 1, 1 minus 1. C is a concatenation of A and B in the row dimension. And D is the concatenation of A and B in the column dimension. And the E is to make a even larger matrix using first matrix A as its item 1, sub-item 1, 1, which is 1, 2, 3, 4, the upper left of the E matrix. And the upper right part of the E matrix is 10 times A, which is 10, 20, 30, and 40. And similarly, the lower left is minus A, which is negative 1, 2, 3, 4. And the lower right corner is matrix B, which is 1, 1, 1 minus 1. And there is also a built-in function for matrix concatenation or duplication, which is repmat. It's simply replication matrix. And here, F equals repmat A to 2. That will replicate matrix A 2 by 2 times. So here you can see the output for F is 1, 2, 3, 4, 4 times. And also, there is a very short video to show some special matrices, built-in matrix in MATLAB, such as I, which returns a m by n matrix with 1 on the main diagonal. And you already know zeros and ones built-in functions, which can make m by n matrix of zeros and ones. And also you can extract the diagonal of a matrix in some matrix calculation. And also you can generate a matrix with random numbers. And some more specific matrix such as Hilbert matrix, inverse Hilbert matrix, magic square, etc. And feel free to try those and use help to